Alright. So yesterday we talked about binomial probability. We're going to do one problem, we're going to review it, and then we're going to move on to some new stuff. So remember, we have trials in binomial probability, and there are a fixed number of trials. So it always tell you you're flipping a coin 8 times, flipping a coin 20 times. It always tell you how many times you're doing something. Each trial there are only two possible outcomes, success and failure. And remember, success doesn't have to be a good thing, like that number 2 on the homework. The squirrel forgetting where he put his walnut was actually a success. Right? It's no good for the squirrel, it'll probably die if it doesn't find any walnuts. Probably the success is the same in each trial, and each trial is an independent event. So, that was all for an exact probability, right? All we did yesterday was when we did exactly 4 4s or whatever. When we rolled exactly 6 5s. We flipped exactly 8 heads. What if we're computing at least or at most probabilities? So if I say I flip a coin 8 times, I want at least 6 heads. That means I could get 6 heads, or 7 heads, or 8 heads, right? So that's what we're going to work with today, is at least or at most. And what's going to happen is we're going to use our same binomial formula, except now we're going to do it more than once. We're going to do multiple times and add them together. So when we're computing at least and at most probabilities, it's necessary to consider, in addition to the given probability, all that are larger if it says at least, or all that are smaller if it says at most. Okay? So what we're going to do is we're going to add those together. We're going to add those probabilities together. Does that make sense? Yes? No? It's really quiet without Patty here. Alright. So first of all, like I said, we're going to do one problem like we did yesterday. We're going to do exactly. So it's probability that Kyla will score above a 90 on a math test. It's 4 out of 5. What is the probability that she will score above a 90 on exactly 3 of the 4 tests this quarter? Well, what are my n and r values? How many total tests is she taking? 4. So that's my n value. What's my r value? 3. I want her to get above a 90 on 3 tests. Okay. So my probability of success is going to be the probability that she gets above a 90, which we said was 4/5. The probability of failure, then it would be what? 1/5, right? It's going to add to 1. So 4/5 and 1/5. So we're just going to use our binomial probability formula we've been using yesterday. We have a combination of 4 things chosen 3 times, times my probability of success, 4/5, to the r power, or how many times do I want her to succeed, the 3rd power, times 1/5, to the n minus r, or how many times do I want her to fail, power, the 1st, right, 1 power. And I'm just going to punch out my calculator. Do I need to do that on mine, or do you guys have that figured out by now? What was that? Do I need to do it on my board? No. No, you guys can do it in your calculators? Okay. What do we get? Approximately what? 41%. There's a 41% chance. Okay? So that's what we did all yesterday. Exactly 3 of 4. Well, what if we change the problem to say, same sort of thing, she'll score above a 90 on a math test, still 4 out of 5. Probably she'll score above a 90 on at least 3 of the 4 tests. So at least 3 means my n is still 4. What's my r value now? What could r be? What? 3 or greater. So it could be 3. But it can also be 4, right? If she scores on a 4 to 4, that still satisfies what we want. So it says at least we want 3 or greater, so 3 or 4. Probability of success stays the same. Probability of failure stays the same. How do you think we're going to go about doing this? Just do it twice at different numbers, right? So if r equals 3, so I'm going to put that here. Do you think I should write that out again? Didn't we just do this? Yeah. We literally just did it in the problem above. What was the decimal So what I would do, guys, when I'm doing problems like this, write out the decimal too. What was the decimal for that problem? To like 4 spots. Let's go 4 decimal places. 0.4 what? 0.04 or 0.4096. Okay, so R equals 3 is approximately 0.4096. I already did that part. I did it in the problem before. So now all I have to do is for R equals 4. If she gets a 90 or above on 4. Well, 4C4, right? Combination of 4 things chosen 4 times, times probability of success to the R power, which is 4, times probability of failure to the n minus R power, which comes out to be 0. Can anyone put that in their calculator already? Or I need to hold on a second. Anna, did you put it in your calculator?
Yeah, I don't know. Is it the same thing? That's what I got, but yeah. Okay, so 0.4096.
0.4096. Yeah, it comes out to be the same thing. That won't always happen, but in this case it does. So what do you think I should do with these 2 probabilities? Add them, right? Because the probability she gets a 3 or 4. So I'm going to take these 2 numbers and I'm going to add them together. Comes out to be what decimal spot? What decimal point? 0.8192, which is approximately 81.9%. So the probability she gets at least 3 of the 4 tests of a 90 or above would be 81.9%. That makes sense? Yes? No? Do you have any questions? I think we have, what, 2 more problems to try? Okay. Let's try another one. A bag contains 6 red bingo chips, 4 blue bingo chips, and 7 white bingo chips. What is the probability of drawing a red bingo chip at least 3 out of 5 times? Well, my n value, my number of trials is 5. I'm pulling 5 times. My R value, at least 3 could mean what? 3, 4, or 5. So I need to do all 3 of those. My probability of success. What's the probability I pull a red bingo chip? 6 out of 17. Where do you get 17 from? Add up the bingo chips, right? There's 17 total. Well, there's 6 red, so probability I get a red is 6 out of 17. So if that's a probability of success, what would my probability of failure be? 11 out of 17, right? These have to equal 1 if I add these 2 together. So go ahead, let's do each of these. R equals 3. 5C3 times 6 over 17 to the third times 11 over 17 to the, well, why can't I think? The second. N minus R. Whew. 5 minus 3 is tough sometimes. So that'll be the first one. Then R equals 4. 5C4 times 6 over 17 to the fourth times 11 over 17 to the first. N minus R. 5 minus 4. And then for R equals 5. 5C5 times 6 over 17 to the fifth times 11 over 17 to the 0 power, right? Because 5 minus 5 give me 0. So you just got to punch all 3 of those in your calculator. Did anyone do any of them so far? Yeah, let's go 4 for now. Right before you change it to a percentage, just go to 4 spots.
So round to 4 places?
Yeah, round to 4 places. So I'll give you a second to punch all that stuff in your calculator. Did anyone do the first one where r equals 3? No one? Dom, did you do it? What'd you get for that first one for a decimal? 0.1841. Good. Stetner, did you do the second one? No. So you can do it in your calculator right now? So you get good practice, make sure you're doing it correctly. Colton, did you do the third one?
Yeah.
We'll go to that one since we're waiting on Stetner.
0055.
0055. 0502. Thank you, sir. All right, and what should I do with those three? Add them all together, right? When we add them, we should get 0.2398, which means we have about a what % chance of getting at least 3 reds? Approximately 24.0% or 24%. Good. Any questions? No? Alright. I'm going to help you list all the stuff for this, but then I want you to try it on your own. Okay? Family consists of 3 children. What's the probability that at most 2 children are boys? So at most means it could be 0, 1, or 2. So my n value, my total number of children is 3. R, at most 2. So 0, 1, or 2. Probability of success. What's the probability of having a boy? For the sake of this argument, we're going to have boys or girls. Okay? What's the probability of having a boy? What? 50% or 1/2, right? You have a boy or a girl for the sake of this problem. So probability of failure then is 1/2. We'd be having a girl. What? Go ahead and try it. Do the problem. Let's see what you get. If you're stuck, let me know. When you're done doing it, you can check your answer at mine. But don't put your notes away once you've checked your answer. About another 30 seconds, we'll say. Alright. How many of us got that answer? How many of us got that answer by doing it that way? Billy, you didn't do it that way?
Almost
Almost done. Alright. Is there another way you think we'd maybe do this? What? What do you think? Oh, you don't. You think there is one?
Yeah.
Okay. You're right. There's another way we could do it, and it'd be quicker than the way we just did it. Can anyone think of what it might be?
Realize like the second and third calculation you did at the same.
That is true. However, that's not what I was thinking. So like we calculated if they had 0, 1, or 2 boys. Well, what do all of our probabilities, the probabilities of every chance have to equal? 1, right? Now, those are just 3. There's a 4th probability. What's the 4th outcome that could have happened? All 3 boys. So what happens, you think, if we did just all 3 boys and we did 1 minus whatever we got? Should we get the same answer? Yeah, so sometimes, like on the homework tonight, I don't know, might be a little bit easier to work backwards. So instead of doing it this way, doing it 3c3 times 1/2 to the 3rd times 1/2 to the 0, getting 0.125, and then subtracting it from 1. Right? Doing one calculation and doing 1 minus saves you a lot of time compared to doing 3 calculations and adding them up, right? So sometimes that way, working backwards, might actually be a little bit more efficient. Alright? Does that make sense? Okay, any questions?